So this is it. We've got one more lab. So welcome to CCNA3 version 7. Remember, if you're looking for this particular assignment, you click on assignments. And it's going to be right there in your list. This particular assignment is a packet tracer. And all of those ones are just in the assignment heading, at least as far as assignments go. If you like the way that they're organized via modules, you can access the same content in there. So this is what we're doing. It looks like this. Right now, we only have a single router, but 2 devices, and we're going to write a extended access control list for each one. For the first one, we're going to filter on FTP. The second one, we're going to filter on web traffic. Let's do this. All right, so part 1 tells you to configure the router. So we'll do that. And the CLI, as is tradition. Expand that out there a little. There we go. Okay. We enable it. We get into global configuration mode. We do an access list. So this particular one's a numbered access list. The first part, they just want to show you that the beginning numbers are standard access lists, and these ones are extended access lists. There's actually more number ranges than that, but that's what packet tracer shows. There's another standard, another extended. And I think there's other types of access lists as well. But you don't have to worry about memorizing those numbers because you can use the question mark. That's the whole point there. All right, they have you do the question mark again, which is good practice. But what we're going to do is we're going to what's called whitelisting traffic, or we're going to say what's permitted, and then everything else is denied. Easy peasy. So I want us to do FTP. We go like that. You'll notice that there's nothing that says FTP. Well, FTP uses the TCP protocol. In fact, these two guys, TCP and UDP, are the only layer 4 protocols. So for the rest of these guys, you won't do the port number. But for these ones, since it's TCP, we have a protocol called FTP that uses TCP. It wants us to do traffic from 172.22.34.64. And if we look over here, that's this network right here. Now that last octet is non-zero because it's a /28. 22.34.64. And then we need a wildcard mask. They calculate it out here for you. Oh, sorry, it's a /27. So great. We put in the wildcard mask 0.0.0.31. They show you how to do that. And then we need a destination. And for us, we only want traffic going to this server. So we're going to put in the IP address for that server. And our network knows him as that. And I didn't put the host keyword. We only want that guy. You can also put a all zeros subnet mask, but in fact, let's do that. The alternative to writing the host keyword is, if we go to the question mark here, it says a destination wildcard, and you can do that. In fact, I wonder if it converts it to the host keyword for us. But I'm not that I'm not that curious. Let's just get this done. All right. So recall this is a layer 4 protocol. So we need to say what port. And we just want one port, so we use equal. There's other ones in there, but including the established keyword, which actually would be fine to put in as well. But the range and these other ones do more than one port number. So greater than, less than. We just want things that are FTP. We just want to permit the FTP protocol, no others, and then like that. And then we also wanted it to be, we want this guy to be able to ping there so that we can, verify connectivity other than using FTP. Technically, it's layer 3 when you're using ICMP. So it's a different level of connectivity that you would be checking. I mean, if you can connect with FTP though, then you know that the layer 3 is working fine. Host 172. Or this is the server IP address, and the host keyword says just that server. So not the entire network's worth of IP addresses. What did we do here? Oh, but I skipped a number. There we go. Okay, so there it is. And then if we do and we do show access lists. There it is, and it looks like we got it. Okay. And you'll notice that it changes the syntax to more of the way that the named access lists work. And that's what we're going to do next. So a named access list can use a number, technically, but they're more recent, and a lot of times access control lists are things that get developed over a matter of years. So you might have one that was formed in a prior version of iOS, but they didn't have named access lists. So let's apply this guy. Gigabit Ethernet 00 group. There we go. All right. So now we're locked and cocked. You also notice that we're already half done. And it's always good practice to save. And we'll save at the end too. All right, verify the ACL completion. So we do this by going to, well, let's close that. PC1. And we'll do desktop command line. Make an FTP to 172.22.34.62. And it connects. We did quit. Not sure how necessary that is. So we're just going to close this thing anyways. All right. Same router. Different interface. Now we're talking about this guy right here, 172.22.34. It's .98, but it's on the .96 network. Plop that on there. Now, expand this. Now, let's cook. All right. So, in this case, we're going to get into like IP access list configuration mode, where we specify that it's an extended access list, and we're going to name it HTTP only. So, the only type of traffic we're going to allow is HTTP. That's the goal. Permit TCP 172.22.34.96. That's our network with the PC on it. In this case, the network is a /28. So the last one was /27, it's /28. First 4 bits belong to the network. And the wildcard mask looks like that. Okay. So yeah, HTTP is it uses TCP. We only want to go to this single destination, 172.22.34.62. Surprised I don't do this with the all zeros as well, just so you get to do both. And in this case, we could put in a number, port number 80, right? But they even specify www for you. Nice. There's some very popular ones that have the name in there. It makes it easier to read too. Okay. And then we want to be able to ping to, remember ICMP is a layer 3 protocol, so we don't have to specify a port. And put in the address of the destination, which is 172.22.34.62. And voila. We do end. We do show access lists. We can see we already had some traffic going through to the FTP server. And then this is the access list that we just did. So we're good there. Go to the interface. Interface, gig, 0/1. And IP access group. HTTP, you'll see it auto completes. No. HTTP only. And all right. So you'll notice that when we apply these, we apply them both times as close as possible to the source network. We could also block them on the outgoing interface here, but then the traffic's going to transit the router, I guess, a little bit. Actually, the difference in that efficiency probably wouldn't be very big. But if there was, say, another router up there, the traffic would go a considerable distance before it got filtered and might take up bandwidth for packets that we're just going to drop anyways. So extended access lists, much more efficient. Let's finish this up. We'll end, do the copy, run start, just to make sure we're in the habit. And then we're going to do some pings. And we'll open up the browser. So we'll ping. Here. Let's open that up. So we do the easy ping. Easy ping from PC1 to the server. Successful. Very nice. This one, I need to ARP first. Nope. Also successful. So we can ping. Can we ping from one to the other? That's a good question. No, we're blocking that traffic. It's good. exactly what we want. Now, can we get on PC2? Go to the browser and get to the home page of the server. And there it is. We've successfully created a extended access list, both named and numbered, and verified the functionality. Good luck. Don't forget to do the exam at the end. And this will conclude the course. Course continues with CNET 156 Bravo. And you can sign up for that still in WebAdvisor. Okay, good luck.